This is the second example that I chose from chapter 8. It's example 3. In this classic example of momentum conservation, we will see why a rifle recoils when it's fired. A marksman holds a 3 kilogram rifle loosely so we can ignore any horizontal external force acting on the rifle bullet system. He fires a bullet of mass of 5 kg horizontally with a speed of 300 meters per second, and they're asking us to find what is the recoil speed of the rifle and what are the final kinetic energy that of the bullet and the rifle. So I did this free diagram. Here is the rifle with we need to find the velocity of the rifle, the mass of the rifle, and here is the bullet, the velocity of the bullet, and the mass of the bullet. So to find the final velocity is gonna be equal to momentum in the x direction initial equal to momentum in the x direction final equal to 0. So it's gonna be 0.005 times 300 plus 3 times the final velocity of the rifle in the x direction equal to 0. So the final velocity of the rifle in the x direction is gonna be negative 0.500 meters per second. To find the kinetic energy of both of the rifle and the bullet, we're gonna use this equation. Kinetic energy is equal to 1/2 mass times the velocity squared. So it's gonna be 1/2 the mass of the bullet in this case times the velocity 300 squared is gonna give us 225 joules. That's the final kinetic energy of the bullet. To find the final kinetic energy of the rifle is the same equation. You plug the numbers and it give you 0.375 joules. That's the final kinetic energy of the rifle, and that is how you solve this example.